Hello everyone, in this video we are going to talk about the power rule for exponents. There's actually several of these. We'll do two in this video and we'll save another one for another video. So for power rule for exponents, if m and n are positive integers, then a to the power of m all raised to the power of n equals the product of those two exponents to that base. So how does this look if we were dealing with numbers or variables? Let's look at the example right here. 3 squared raised to the power of 4. Now we can apply this rule here, where we multiply the two numbers together, in this case 2 and 4, and we would get 3 to the power of 8. There is another way to look at this, and that is writing out 3 squared exactly 4 times, which if we did that, we can add all those exponents together, 2 plus 2 plus 2 plus 2, and we would still get 3 to the 8th. Using this for variables as well, if I add n to the power of 3 raised to the power of 2, multiply 3 and 2 together, and you get 6. This is really it for the first power rule for exponents. All you're doing is multiplying an exponent to another exponent, and you're good. Again, keeping the same base. If you're asked to evaluate the expression, you would go ahead and do so. But for these examples, all we're doing is just multiplying the exponents. Let's take a look at another power rule. If m is a positive integer, then ab to the power of m equals a to the power of m times b to the power of m. So what's different about this one is that we're going to have a couple of things going on inside these parentheses. We're going to have maybe some numbers, we'll have some variables too, it looks like. So what this is and how we can look at it is, think of it as like distributing the exponent to each of the parts inside of the parentheses, and then evaluating them as needed, or just simply writing out with that exponent applied to that specific number or variable, or both in some cases. So here's an example. (2p to the power of 5), quote unquote distributing that exponent to each part in these parentheses here. This gives us 2 to the power of 5 times p to the power of 5. In this case, I'll actually multiply this out, 2 to the power of 5, that's 32. That takes care of this one. Let's look at one more for this video. Let's have 9 and then pq raised to the power of 2. So what's different in this case is that we have this leading coefficient on the outside. We're just going to apply that to the final step once we're done distributing that exponent to each of these two variables, here. So we're going to have 9, and then this 2 is going to be the exponent for both p and q. This takes care of this power rule here. And then here's the first one that we were dealing with, where we had an exponent raised to another exponent. There's one more, but we'll look at it in the next video, so stay tuned. Thank you so much for watching, and I will see you later.